Test, 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 test. test 1 2 1 2 test 1 2. Dear people in the cafe, can you hear me? We are about to start within a few minutes. Would everyone be so nice to slowly come into the Musiksaal venue? Please bring your friends that do. Please bring your friends that do not hear me. We are about to start in the Musiksaal. Yes, yes, yes. The cafe is slowly emptying. I guess that's a good sign. AmsterdamJS is about to commence, dear people. The spring edition. Yes, cheerleaders in the house, in the back. Right, all right. Almost, I guess. Maybe it's time to slowly bring out the smooth jazz because we are about to give this atmosphere a little kick in the balls. All right. If everyone would be so kind to please take a seat, hang up your coat in the wardrobe in the corner. Pull in your friends. Last friends, I guess that's it. Would someone be so nice to close the doors of the venue? And these are so nice. That's great. I don't know which password you need to unlock the magnets, but yes, the password is brute force. Great. I think it's working. Thank you, Nizar. Well, it's 7:03. It's about time to kick it off, I guess. Welcome to the spring edition of AmsterdamJS here in Crea, Amsterdam. Yes. This edition will be all about, well, a wide range of topics, as you can see. I'm excited. Make sure to follow us on our channels to receive updates on our meetups, but also on the conference. My name, you might have seen me here before. It's not my first edition. My name is Tim. I am a JavaScript hacker and an entrepreneur in this city since 10 years already. I have co-founded a couple of internet products, many of which I am still actively involved in. And they are part of my company called Startup Studio Neskio. You can check it out on neskio.co. And we're growing. So I'm always looking to get in touch with driven product people. If you want to experience how companies are created and if you want to learn how to build an internet business, talk to me or shoot me an email or Twitter me or tackle me and then offer me a beer, something like that. All right, as usual, we are live streaming this event. The link you can find on our YouTube channel. Just search for AmsterdamJS on YouTube and you will figure it out. I think Robert also commented it on the Meetup page, so there you can also find the link. All right, we have some great news this time around, because we have a new main partner, and their name is Reactor. You might have heard of them. They have been very active in Amsterdam since 1 year, because they only entered this city recently. They are a pretty large international agency, and they have been originally from Finland, but since a year they have been in Amsterdam, and they have big ambitions there. So they're growing, and they told me that they're nice guys. So you should talk to them. They're in the back there at the red table. If in case you see someone walking around with a gray T-shirt with a big R on the front, well, that's one of them. You can also grab one of those T-shirts here on the table. There's a lot of swag here, also swag from our own brand, from React Amsterdam brand. Yeah, for you to take, one per person, please. All right. Well, I didn't mention the URL yet, but you can see it there. Thanks to Reactor, we have like the most amazing food and drinks in the history of AmsterdamJS, I think, because there's more than ever, it's more varied than ever, and I think we're gonna make it at least to the break with the bar tab this time. So just mention AmsterdamJS at the bar, and they will hopefully give you a free drink. Thanks to Reactor. Applause, applause. All right, our second sponsor, who has been with us for a couple of editions now, is Evolution Gaming. They are also a company located in Amsterdam nowadays, and they are specialized in building 3D games using WebGL, React, Redux. So if that's your thing, go check them out. They're also hiring. And then a quick mention of a nice project of my friend Robert here. He's trying to sort of improve or fix the local job market, and he's doing so by this new initiative, devfriendly.io. Currently focused only on 70k plus JavaScript vacancies. So if you feel like you're at that level, go check them out. No recruiters involved, just community-based effort. And then, of course, a quick mention of our annual conference, because it's coming to a venue near you soon. To be precise, it's going to be May 31st, full day of workshops, and then June 1st will be a full day of talks. It's in the Zuiderkerk. I don't know if you know this venue, but it's pretty nice, wonderful, historic, and central. I'm quite excited to see how that turns out. Great work in finding that location. And then we have a pretty awesome lineup as well, I think. Douglas Crockford, maybe you've heard of this guy. He wrote a book some time ago. Has something to do with JavaScript. In case you don't know him, you should come, because it's gonna be an interesting day. And maybe you meet me there as well, but that's not sure yet. All right. Of course, we have a discount code for all our loyal community members. AmsterdamJS conference couldn't exist the way it currently exists without the meetups, without the community here that has been running for many years now. So to honor that, we have a special discount for the community members. So if you want to grab a ticket and you are in this room tonight, then you can get 15% discount using this discount code. Don't forget that. All right. I'm almost done talking. This is going to be the schedule for tonight. But before that, before we kick it off, I have a personal announcement to make. Because 2 years ago, I joined forces with Robert and with Dennis and with Nikolai and with Rick. And I took over the organization of this meetup group from Sergi, who moved to Barcelona. And my personal motivation has always been to keep AmsterdamJS alive, not only because I have been enjoying very much attending these events since the early beginning in 2010, but I also felt that it needed to be reestablished as sort of the JavaScript group in the city and in the country. So I took it over 2 years ago with this great team of people, and now 2 years later, I'm pretty happy with where we are. Because look at this, we have been doing consistent events every 3 months. Great turnout every edition. Tonight is no exception. Great growth of our community. I think 2 years ago we had like 1,100 people in the meetup group, and now more than 2,300, which is like astounding growth. It reflects, I guess, the potential of JavaScript in Amsterdam. And then, well, look at the nice venue, all the nice industry support from Reactor, Bluefront, and all the other companies that have been supporting us over the years. Consistently high-quality speakers, thanks to all of you. And I've personally enjoyed very much all the fun experiments in the schedule. For example, maybe some of you remember Never Mind the Buzzwords by Rick, which was hilarious at times, but technically not always very on point. Didn't matter, it's a meetup after all. And then we had the fireside chat for a couple of previous editions. I also enjoyed that very much. It kind of demonstrates that you can basically invite anyone and they will just eagerly show up and you can have a chat with them. That's cool. I hope it will make a comeback at some point in the future. And last but not least, of course, AmsterdamJS now is not only a meetup group, but it's also an annual conference. And well, like I just mentioned, it's looking really good this year again. So I trust that this conference is here to stay. I'm pretty sure that this won't go anywhere. I'm really eager to see where this goes in a couple of years from now. Especially given the fact that I think that Amsterdam and JavaScript are two things that have a big future. So let's see where the conference goes. And I'm very proud to realize that these 2 years have been more successful than I could have ever hoped for. We have firmly reestablished AmsterdamJS as the mothership JavaScript event of the city. So be proud to be part of that. I think that's a rightful feeling to have. As a result, I have decided that today would be a good timing for me to take a step back as an active organizer and to make room for other people to pass the torch on to others. I'm very confident that the meetup is in great hands with Robert and Dennis. But, of course, they can always use your help. Because I've said this many times before, but I'm going to say it once again. This is a community thing. There's no hidden agenda here. There's no corporate interest. There is no funding other than the stuff that other than the money that we managed to secure by the support of partners. The only reason why this exists is because people like you and me and Robert and Dennis have decided that they felt it would be a good idea to put in the effort and the time and the passion. Because I feel this city deserves a community like this, an event series like this. So if you feel like you can maybe help out in any way, maybe by researching speaker proposals, maybe by communicating online about our events via email or Twitter, or maybe by doing some sponsor account management or onboarding new companies and supporting us, please let us know. Because without your help, without all of you thinking once in a while, maybe I can contribute somehow, this is not going to have a future. So I've been pouring in a lot of time and effort in the past 2 years, and I'm very happy that I did so. But I hope now I can pass it on to other people without being worried that it kind of dies all of a sudden. And I'm very confident that Robert and Dennis are great at continuing it. But I also hope that there are other people that feel kind of happy to join in. So let us know in case you think you can do something. All right. That was a lot of talking by me. Thank you. Thank you. All right. Maybe now it's time to just move on to the real stuff. It's time for me to announce our first speaker of the day, of the night. His name is Sendil Kumar, and he is going to talk to you about WebAssembly, Give a warm round of applause to Sendil.
Hello, can you hear me? Hello all, fellow JavaScript developers, and welcome to Do Things with Better and Faster with WebAssembly. And I'm Sendil Kumar. I'm a full stack developer at ZBA Labs. I'm a co-dev team member of JHipster. How many of you heard about JHipster here? Cool, yeah, we have quite a few hands here. I'm a team member of Webpack. I'm also part of Rust Wasm working group, where we decide the future of Rust and Wasm integration. And I'm a big open source lover. You can see me contributing to a wide range of projects in GitHub. And I'm also promoting open source everywhere I go. And you can reach me over here at Sendil Kumarian in Twitter and GitHub. So how many of you are here are full stack developers? Cool. Yep, we have a lot of full stack developers. How many of you do full stack only in JavaScript? Quite few, okay. How many of you love that, doing? Ooh, okay, we have quite a few hands now, great. Okay, how many of you are C and C++ developers here? Ooh, we have 3, 4, great. Rust developers? 1, awesome, great. So what these things offer, like C++, Rust, they definitely offer types. What else they offer you? Speed, yeah. Portability here. Yeah, of course, they offer those kind of things. It offers safety, especially in case of Rust. It offers you a lot of safety. It gives you more control to what you write, things like that. And it's very closer to mission, which means it runs at faster speed. On the other hand, I'm in a JavaScript meetup. I'm not going to ask how many of you are JavaScript developers, but let me ask you this question. How many of you are not JavaScript developers? Ooh, we have 1. Oh, 3, great. So for all others, what do you do to increase the performance of your application? More servers, yay, okay. Anything else? Cache, of course, yeah. Lazy loading, yeah. So yeah, we do some sort of things, some sort of magics to make that happen. We obviously make use of type system in case of JavaScript to make it faster. We reduce the amount of DOM manipulation via JavaScript. We do code splitting. It's kind of lazy loading. And we do async and differ using script modules. We minify stuffs in order to increase the performance of your application. We do have something called service workers that help you to do caching and all those stuffs. And we do have immutability and some other things like JS engine-based optimization and profiling. How many of you have done this thing, like optimize your functions? 1, 2? Oh, we have quite a few, 10 people around. Yeah, great. So these are the things that we do in order to make sure that our applications are running faster and better. Let us go for a performance question. What do you think will have a higher performance? We have option A over there and option B over here. The only difference is the second line. Yep. How many of you say option A? Okay. How many of you say option B? Ooh, a lot of persons saying option B. Great. But the answer is option A. Yes. You guys know why?
Isn't this simply because it's highly optimized for the left case, and on the right one it already has to allocate the multiple places?
Yeah.
I'm not sure that makes total sense. But.
Okay, allocation is part of the answer that you're talking about. It's because of packed and holy array. Any of you heard about packed and holy array here? So when you create an array with new array of 3, your JavaScript engine doesn't know what to do. It creates 3 array size of 3 with undefined elements inside it. And that is a holy array. But when you define an empty braces, your JavaScript engine knows, okay guys, something is gonna be there, but I don't know now. So I'm not going to put in an extra effort in defining that stuff. then you can have a much faster. And if you want to know more information about this, you can follow the link below there. It gives you much more detail about it. And this is the statistics that is taken. The packed array will have higher operations per second, but on the other case, the holy array have much more lesser operations per second. Uncertainties. These are the things that we are talking about here. So you have a lot of uncertainties in the languages. And all of us believed that new array will give a better performance, but it's not going to happen because there is uncertainty there. And how do you solve these uncertainties? What are kind of things that you do for these uncertainties? Anybody? What is this? Yes, it's an internals of engine. And in order to fix the uncertainties, you have to understand how the engines work. Internals of engine, how it is implemented, what you have to do in order to increase those performance. On the other hand, what are the things that we usually used to do in order to get maximum performance out of the JavaScript? For example, applications using WebGL, application using games, applications doing all those high-end stuff. And also for the smaller stuffs, what kind of things that you're doing? Like you do certain stuff based on engine-based tunings. Like there are multiple JavaScript engines available. Certain operations are faster in one type of engine, and certain operations are slower in another type of engine. So you do engine-based tunings there. And there are some shortcomings in the engines itself. So all your engines have shortcomings. Monomorphization, anybody heard of this word before? One person, yeah. So, why do we go to TypeScript? Basically, we go to TypeScript because it gives you types, which ensures when the JavaScript is actually running in your engine, it gives a monomorphic code. That is a code with only one type, which means engine doesn't have to do a lot of optimizations in order to take care of polymorph, that is different types. How many of you know adding an optional argument inside your code will reduce the performance of your application here? 1, 2, yeah. And it's so time consuming because you will have some functions that is rendered much more slower, and you have to spend a lot of effort in order to drive the performance out of it, which is time consuming on hand. And you do have to do micro benchmarking here. You have to go through all the functions that you have written one by one, and then make sure all are running at the high performance. Of course, okay. Of course, you have to know the concept of packed and holy array when you're working with arrays. On the other hand, what does it offer? Like, you have done all the optimization that we have seen at the previous slide, but what we'll end up in is a code that is kind of messed up. You cannot maintain that code so far because people who are coming outside, who are coming newly to the application will not know anything about the code, why I've done in this way, why it has been done in this way. But on the go, sometimes JavaScript engine itself changes. Like, V8 is getting released every now and then. And every now and then, they are attacking a particular part of the performance, and then they're increasing the performance, which means whatever you have done, whatever the messier thing that you have done in order to increase the performance will be outdated, and people has to change that stuff. And you have a problem of maintainability here. So there is a trade-off between uncertainty and performance, and most of us will stick with uncertainty and don't care about the performance, because already JavaScript gives you more higher performance when it's running, but driving the entire performance out of the application, nobody is going to care because it gives you uncertainty and also the maintainability in the code. So how better will it be to run the consistency and speed of the application using the native code in the browsers? It would be nice, right, to run your native code in the browser where you don't need to worry about all those things that we have just talked. So introducing you guys WebAssembly. How many of you have done WebAssembly? How many of you have heard about WebAssembly, worked on it? How many of you worked on it? Cool, nobody, okay. So WebAssembly is nothing but binary encoded stack machine. So it's a set of instructions that you give to your computer, and it runs those instructions. That's it. And it runs on your browser, which makes it much more simpler. So you can compile your native code for a browser environment and run it in the browser. So that's what WebAssembly is all about. And of course, it's supported by all the major languages or all the major browsers that we have. It's fast and efficient. It's pretty safe because WebAssembly itself runs in a safe execution environment, which makes it pretty safe. It's binary encoded. It's debuggable, so you can debug the WebAssembly stuffs. And it's developed as a part of open web platforms, which means it's available in all the browsers openly. And one cool thing, just before we jump into WebAssembly and see what kind of things that is offered, you have to know WebAssembly is not a replacement of JavaScript. It's not going to replace your JavaScript at any point of time. It helps you to integrate well and create a maintainable code, and it always focuses, WebAssembly always focuses, as a working group member, we always focus on symbiotic relationship between WebAssembly and the JavaScript. So how many of you here know how a JavaScript works inside a JavaScript engine? Sorry?
I said completely.
Not completely, at least the idea of how it works. Yeah, so let's go a crash course into it. So immediately when your JavaScript file is getting downloaded on the machine, on the browser, it starts to parse it. It tries to convert into AST. AST is, what is AST? Yeah, abstract syntax tree. And once it is parsed, it tries to interpret this JavaScript and goes straight away into execution mode. But on the other hand, there is a profiler which comes into picture, which looks on the things that are executing, and then it checks, okay, this function is getting called a lot of times. Okay, let's mark this function as a hot function. And once it is marked as a hot function, it tries to compile them, and it tries to optimize the function such that it works best. So once this optimization is happening, JavaScript, instead of using the interpreter way of interpreter into execute the stuff, it goes via the optimized way, which means it works much faster. But when it goes really hot, like the function is getting called like millions of times again and again, JavaScript takes some assumption, the engine takes some assumption, and then re-optimize the entire stuff, which means it's much more faster. But definitely when you compile, optimize, and then re-optimize, there are some nanoseconds or milliseconds or microseconds of time lag that is happening because the engine has to take this code, it has to compile it, it has to optimize the thing, it has to generate a code and then put a reference to it. So which means you're using a lot of time there. You're missing a lot of time there. And finally, it executes that stuff. At the end of the day, you garbage collect everything, and sometimes your application may pass at this point. But on the other hand, how WebAssembly works. So steps are smaller. It starts to decode. So you're binary encoding the data. As soon as the browser finds a WASM file is downloaded, it tries to decode the entire data. Once it is decoded, it tries to compile it. So the code is already compiled and optimized. So you need not worry about optimization. But this compilation part is much more smaller. It compiles in the browser inside the JavaScript engine, and finally it executes it, which makes it much more simpler and faster to get started and running. Let's see how you build a simple example in Rust. I'll be focusing mainly on Rust here. So this is a simple function. You don't have anything here. It's just a simple function that says add 1. And it just takes an integer and adds 1 to it and then returns it. As simple as that. Just before we go there, how many of you, okay, what is the numerical format that JavaScript is using? Sorry?
ISO something 6.
6?
ISO 6.
Sorry? Okay. It's using F64. So all the numbers that you define in JavaScript land is F64. But on this case, you see Rust is using I32, which is much more efficient than F64, correct? Yes or no? Okay, it's yes. Fine. Let's go ahead. So you run this command. So this WebAssembly compiler is part of Rust compiler now. So you can run this command. It's in the part of right label. So just run this command. It converts your Rust code into WebAssembly code. And what do you get? A raw binary format. So WebAssembly is nothing but a raw binary format. It has an assembly code. How many of you are from electronics background here? Ever written assembly for your 8086? Cool. Great. Finally, so once it is generated, WebAssembly just generates a module. So these modules are small entities. And inside the modules, you have set of instructions there, which helps you to run your code. So you have things like import, which helps you to add all the imports that a WebAssembly module can have, followed by the export. So export will have a list of things that is exported from that particular module. So for example, you have seen add 1 function there. This add 1 function is exported out of the module. So you can specify the export here, followed by function and code, the actual function and code. And here it's defined by the keyword function, so it has actual function. On the other hand, you have a start. This start is where, this start is a starting point of execution. If you haven't defined one, it will wait till you call the function there. If you have defined one, the moment WebAssembly module is loaded, it starts to run the start function. And then you have global, where you can specify the global parameters there, like the global variables, followed by the memory. So memory is where you specify the memory that Rust and JavaScript shares. So this is one thing that you have to make sure, like everything operates on basis of memory here. So you tell the WebAssembly module that this is a kind of memory that you have to use, then it sticks to that memory and works on top of that memory. Added to that, you have element, you have table, and you have data. So these are the extra informations that you can add inside element, add inside the WebAssembly module that is shared between the application, the JavaScript, and WASM. So this is really helpful when you do the boundary crossing, because JavaScript literally knows which memory to attack, and WASM module literally knows from which memory it has to load stuffs. But that raw binary format is not readable. To make it readable, we have WAST. WAST is nothing but WebAssembly text format. It's really helpful in debugging. So we have seen the WebAssembly modules are debuggable, which means it's debuggable with the help of WAST. So WAST is a literally translation of WebAssembly binary code. Let's go through it one by one. You have a module. So everything is wrapped inside this module. Followed by that, you have type. So this type stores the type information of what you have. Currently, we have types like i32, func. Func is for function type. And this function has a param, which takes an i32 type. And then it has a result. And how many of you know Lisp here? Great. These brackets look like that, right? Yeah. And then the actual function itself. So it's defined by function keyword. And whatever that is denoted with the dollar notation. And that thing is a variable inside here, so you can call this stuff here. And here you can see it's exporting add1, and then it has a type. It defines as $0, which is a variable again in terms of WASM module. And you have a parameter result. And if you see the 3 lines from the bottom, those are the actual code. That is what you have written. Like you get the local value of $p0, and this $p0 is defined in the param there. And then you do add constant 1, i32 of const 1, and then you do i32.add. This i32.add is nothing but your plain assembly instruction, which will be converted in the raw binary format there. And then you have table. So currently, table takes any func as a type, and it's the only thing that is available now, but you can add in, like, in future, there will be a lot of things that will be added to it. And then you specify the amount of memory that your application has to use. So this really helps the WASM module to understand the amount of memory it has to use and the memory from which it has to use. So it's if we have a memory, you have to export this particular memory, and this is the initial size of the memory, like 17 bytes of information that you are exporting out. On the other hand, you specify the actual data, and this is really helpful when you want to share some data between WASM modules or between JavaScript and WASM. So when this boundary crossing is happening, if you want to share some data in between them, you can use this data. Any questions so far? Am I talking some alien assembly language?
In the body of the function, you can use the assembly language?
Actually, this is assembly code that is generated, and this is a textual format of that code. So you can call an assembly language from a JavaScript, as well as you can call the same WASM module between WASM modules. And you can also call your native application. If it is running alongside, you can also call WASM to native application. You can do that stuff. Great. OK, moving forward. Yeah, fine, we have WASM, we have WAS that is generated by the compiler. What is there? How do you load them? How do you add them into your application? I hope the text size is bigger enough for people here. Right. So here you have 2 options, like just written in 2 ways. First is like you just take fetch the WASM file, and then you convert that into an array buffer, and then you feed it to WebAssembly.instantiate. WebAssembly is a window object, global object. It's available in all the browsers now, all the major browsers now. And yeah, you can instantiate the object. And from the result that is in the 3rd line, you can export that particular stuff. Like you can have a list of objects there. So this result.instance will give you objects like memory, all the things that we have seen, memory, exports, imports, and all the stuffs that we have seen in the previous section will be listed here. So this is an object that you have to work on top of it. And when you say add 112, you end up in giving a result of 13 there. Okay. And then you have using compile streaming. So here it's like you don't worry about fetching the stuff and then converting that into an array buffer. The browsers will give you a compile streaming method, which helps you to fetch the stuff, compile it, and then give the compiled version of the module, and use the compiled version of the module to instantiate stuff. So it's much more simpler. And even you go one step deeper, it tries to instantiate the compile module. So you just have to fetch it and then instantiate the particular stuff. But this is currently supported in fewer browsers. Not all browsers support instantiate streaming. Also, compile streaming and instantiate streaming are extensively supported under HTTPS for security. Good. Finally, the streaming compilation actually speeds up the WASM performance. How does it speed up? Anybody? Because you're compiling on fly. Like, this is just a binary code, binary data, raw data that is coming from the server, that is coming from the browser. You just compile it on the go, which means you have much more higher performance. In JavaScript, there is no way of doing streaming compilation now. The main reason is it has to generate an AST first. But in case of WebAssembly, since we are dealing with binary code, you need not worry about ASTs here, which means you have 10 to 15 times faster on doing streaming compilation. But worry not, streaming compilation will be coming to JavaScript sooner. And there is also an ECMAScript module specification for WASM. This enables us to load the WASM files as an ECMAScript, ES modules. And it's still in very early stages, talks are going on, and I guess yesterday there was an awesome article from Lynn Clark for this particular stuff. You should check that out. Okay, let's go to the demo time. Enough of boring talk. Okay, I'll be doing 2 demos here. The first demo is I'll be using WASM bindgen, which is a tool that helps you to include your WASM modules in your browser. It has a lot of cool functionalities added to it. And in the second demo, I'll be using Webpack, and then I'll show you the performance difference that it's giving you. Okay? So there is only one person has worked on Rust. I'll just go through this file. Let's just zoom in a bit. Okay, so fine. So this is a file that has been generated. So this is cargo toml is something like your package.json for your node modules and stuff. So here you define a package, and you give all the necessary information that you want. And then you define a library. And this specifies this library, this Rust library, is capable of running in a different embedded environment. On the other hand, you specify dependency, which is nothing but a crate. In Rust world, it's called a crate, while comparing in NPM world, it's called a package. So you specify the WASM bindgen and the version of it. That's it. So this is a Rust file that we have generated, that we are going to work on. It does nothing. It just gives you an alert. Hello world. That's it. So let's change it. Hello world. Yep, let's change it in the JavaScript file. On the other hand, you do have a package.json. So we are going to run this in your HTML file. So this package.json is nothing. It has Webpack CLI. So Webpack has WASM. Webpack 4 comes with WASM, so you can load WASM with that. And followed by that, you have Webpack config file, which helps you to, this is a configuration of file, which has nothing, just an entry, an output, how do you do it, and the mode. So Webpack 4 has mode in it, so just have the mode. Great. And this is just an index.html, which shows stuffs here, and then the index.javascript, which actually helps you to load the WASM module. So let's go ahead to our command prompt. Okay, so let's type in. So in order to generate or build your application, you have to type cargo build target wasm32 unknown. So this is a command that helps you to build a WASM file out of the Rust file that we have. So let's click it. So it tries to compile it, and then it generates a WASM file. So let's see where it is. So if you see here, it generates a WASM file for you. So this WASM file is just the name of your application. And the WASM file is generated. Let's go back.
Could you please show the content of WASM file?
It's a binary format. I don't have to.
0101 hex.
No, it's kind of not exactly in 0101 hex. It's kind of like it has some words in it too, but I'm not sure I can open this and show it here, but probably I can try, sure. Okay. So this is the WASM that has been generated. Cool. Okay, so now what I'm going to do is I'm going to use WASM to convert this WASM file that has been generated, and I'm going to convert that particular WASM into an optimized WASM such that it can be used along the process. So what I'm going to try is WASM -bindgen. I take that particular file and then create an output in the same location that I have. So this will generate an output for me, and if you see, this would have generated bg_demo.js and bg_bg.wasm file. So let's go ahead and see what it has inside. Okay, first we'll see the demo.javascript file. So now whatever generated is kind of very huge here because it has to take into account of all the memory pointers, and also it has to use strings here because WASM in general supports I32 and I64, F32, F64, but it doesn't have a string support inside. So what we are doing currently is like we are manipulating this entire memory into a form of an array buffer, and we give the raw memory location via a JavaScript file, call it as a binding file, and with the help of the WASM works along with it. So that's how we are passing strings and everything from WASM to JavaScript as well as JavaScript back to WASM. So we're just loading the WASM here. So you can see it here, it is loaded as if it is an AS module. But Webpack actually tries to convert into sync stuff, and it works with the help of Webpack. And then it has a lot of all the memory that you're slicing a memory, you use the memory, you have a memory location. With the help of the memory location, it helps and gets all the information. So what you're going to do is we're just going to have an index.js which actually imports a particular demo application. And then once the demo application is imported, it tries to get this. It tries to greet. The greet is a function that is inside your Rust file. So this function, it goes and calls this function inside the Rust file. Great. And one thing to note here is Webpack doesn't allow synchronous import in the basic chunk. So how many of you know about chunks here? Yeah, so many of you know. So you have you can define your application and have a lot of chunks in that, and your main chunk cannot have synchronous module import, and which for WASM, particularly in terms of WASM, your main chunk cannot have any synchronous import. So you have to load it asynchronously. That's why you're using import with braces. So import with braces will do it asynchronous, and then this gives you a promise, and then you go to the promise and then run the code. Let's go ahead and do yarn serve. So this should start the application in 1300. So let's copy this and open up Firefox and then run it. So yeah, so you have hello.world that is calling inside a function in the Rust. So you're calling from JavaScript inside the Rust, and you're passing in a string. Let's go back and say, just for fun, Amsterdam, and you say, it comes here. So yeah, so it goes and calls a Rust, and then it gives the value it gets a value from the Rust. The raw memory pointers will help you to get the values from there, and then it shows cases here. But this is pretty simple, right? Let's go into much more complex stuff. So yeah, so this entire application is available in Webpack examples. It's kind of something, I've just added few other stuffs, few fancy stuffs on top of it, but this entire thing is available in Webpack. So what we are going to try and do here is like this definitely has a package.json which has a Webpack stuffs, and the config.json which loads a WASM. So you can load your WASM with the help of this rule stuffs and everything. And finally, when you go, you have a set of WASM files that has been used. And a function that has a factorial in JavaScript as well as a Fibonacci in JavaScript. So this is a simple one. And you have the similar functions in your Rust or C++, and you have it in WASM code. So let's go ahead and run this particular file. Let's close this one. Come here, run it. Okay, so it tries to run your entire stuff, and you can see the difference of performance here. Your JavaScript one is having higher time. On the other side, your WASM one has a lower time, which means the performance is much more higher in terms of loading your simple application. But what we are doing actually here is, we are trying to call, it's too slow for me. We're trying to call the same function like 5,000 times. We're trying to first warm it up. So in order to play good, we're just trying to warm it up here. And once it is warmed, that is once the profiler kicks in and says, okay, this function is getting called a lot of time, let's mark it as and let's optimize this particular function. And once it is optimized, we're just trying to run it for more number of times. And at the end of the time, we're just calling those functions. And look what it has happened here. So it has like the WASM factorial gets called, and it's like for 5,000 time, it just took to 24 milliseconds. So you have a lot of differences between the performance here. But one thing to note is, like, you can always go ahead and do like increase the performance of your JavaScript using a lot of techniques that we have. Like, we have seen many techniques, and there are a lot of other techniques. You can go ahead and remove the recursive function and then replace it with normal function, since we are using a recursive function here. So since we are using a recursive function, in JavaScript, recursive function is much more slower. So you can go ahead and use a normal function here instead of recursive, the normal one, and increase. But the performance, you will get like 10 to 15% of performance, much more higher in terms of WebAssembly on comparing to the JavaScript counterpart, which is much more easier and simpler. Simply, you're just writing the same stuff, but you're getting much more higher performance. Okay. So the future of WebAssembly, like where we are going, we don't have complete garbage collection in WebAssembly, which means the languages that has garbage collections will not work properly with WebAssembly. That means you cannot convert them into WASM stuff. So that's the main reason why we have C++, C, and Rust, which has garbage collection, which means that you're storing all the memory and all those stuffs inside as something there. And without this garbage collection, you cannot have DOM manipulation too. And the bulk memory operations are not possible. And we have a hard limit of 4 gigabytes here on the memory stuffs. But you don't have any bulk memory operation such that you cannot specify a huge amount of memory in a WASM file, which obviously makes your file into a huge file. On the other hand, the threads are coming to WASM, which means you can run it in multi-threaded application. And you also have you don't have an exception handling now, but community is moving towards and adding an exception handling, which means like nicer error messages that are not handled now. You just application stopped working, things like that. But you can have a good exception handling in future. Any questions? Okay.
Do you understand that you can only write this in Rust, C, or C++?
Yes, no. Okay. So questions you can ask me in the break. Questions you can ask me in the break, okay? So I'm also authoring a book on full stack development with JHipster. If you guys are interested, you can approach me on Twitter. I can give you discount codes. And happy hacking. Thank you.
Thank you, Sendil. Thank you. Thank you for showing us this little piece of this little piece of knowledge that I didn't know about, and I guess many other people didn't know about either. Our next speaker his name is Mikhail Kuznetcov. Kuznetcov. He's going to talk to us about blockchain and about developing smart contracts using JavaScript. I hope he will have managed to connect his laptop when I end this sentence. Have you? Then I would like to have a warm applause for Mikhail.
Can you hear me? Good. Okay. Yeah, fine. So, as guys said, my name is Mikhail, and today I'm going to talk about what is smart contracts and how you can work with them from your JavaScript application. So, let's start. So, quick word about myself. I'm Mikhail. I'm from Moscow originally. I've been doing web development for last 7 years. Currently I'm working for ING investment department, and basically, excited about open source and various new APIs that are available. What we're gonna do? Just quick intro about what is the smart contracts and distributed decentralized applications. What is the setup that you can employ to use JavaScript to communicate with smart contracts? And we'll do a quick demo of using one of the decentralized application to actually change some stuff and deploy it on the blockchain, and see what are the future steps if you are really interested in that. So the current landscape of the tools and technologies is quite wide. That's why we won't deep dive into what is a blockchain or how the contract is compiled. All those details you can find later. So what I would like to achieve is that you can see that you can basically build your own blockchain application from scratch in quite a short time if you know JavaScript and you know how it works. So let's move on. Basically, who here has some slightest idea what a blockchain is? Please raise your hand. Okay, very good. That's what I was expecting to, so I won't start what it is. Let's just go directly to one of the most popular blockchain implementations. It's Ethereum. It's been started around 2015 by a guy, co-founded by a guy named Vitalik Buterin. You probably saw this person in the talks about decentralization, cryptocurrencies, and all that stuff. So it's open source, decentralized platform, and one of the key features why it's being so popular is that it features the ability to execute contracts, any code you would like, let's say, on the nodes of the network. So network of Ethereum has two types of accounts, basically. One is a user, which has ID, and address, and the funding. And the other one is which makes it so different is the contract address. Basically, it's an arbitrary piece of code which is attached to that address, which can be called by the user, and that's how basically the workflow starts. So user calls a contract, then the contract performs some actions, and this action, if it's approved by the contract, can be distributed throughout the nodes of the network, and each node validates it and adds it if it's valid to the blockchain. So what are actually the smart contracts? Besides the formal definition, which is a bit quite abstract, it's basically pieces of code written in a specific language which can be executed on the Ethereum network. Examples, again, you probably heard of those options to create a pension or a trust fund, network democracy, where you can every user can cast a vote, and in the end you see who basically choose which option, and all this information is being stored in the network. It's being transparent and validated by all the parties. Actually, the ICOs so famous last couple of years, a lot of them, they use Ethereum as a platform because of the smart contract. Okay, so what it takes to write actually the smart contract. It's, as you can see, there's a specific language developed which is called Solidity. It wouldn't look very new to you if you used some object-oriented languages like Java or even modern JavaScript. You have basically options to import stuff from other reusable parts. You have the main structure, which is the name of the contract. You have substructures which define the types of data which contracts works with, and you have methods and events which can toggle the state of a contract, or let's say get information from outside world or push it to the outside world. So here I have an example of really simple contract which performs a to-do list where you can add an item, you can toggle an item to be active or inactive, and that's basically what we're going to do in the demo you will see later. So how does this code basically starts working? So the life cycle is relatively simple. When you compile your Solidity code, you have a bytecode which is being deployed to the whole network, to all the nodes basically. And after that moment, the contract has a specific address by which you can call it and call functions on it. And after that, you can interact with your contracts since it's being deployed. So one more level deeper, basically the decentralized apps. Those are the apps like native or in a browser, it doesn't matter, who use as one of the APIs they work with, they use blockchain. So they use blockchain to store the data or retrieve the data. So this is basically the definition, but as you will see later, the apps is nothing more different than a normal one, besides the fact that you can employ the power of decentralization and blockchain. So if we want to write this decentralized app, how we're going to actually connect to the Ethereum? So there is a Web3 provider, which is basically a wrapper on top, which can provide you connection to Ethereum network. You can see here the snippets of code which you may use in your app. Basically, first you connect to your provider, then you may set some defaults, some settings, select an account, and so on. And after that, it should look quite the same as you would be using, let's say, some Ajax calls or something. You just have your main object to which you call the methods on it. So you check if the status is connected or not. You may validate if this address is an address that you can actually do something, and then you can send transactions, check the balances, all that stuff. It is quite straightforward. As I said, connecting to a network. Basically, what is a network is the blockchain, right? There are different networks in Ethereum. One, let's say, production one with real money, and there are, I don't know, a bunch of test networks which are there just for developers to test their algorithms and for a variety of test purposes. And of course, for local development, you would prefer to have something running locally. For that, there are several tools. One quite popular was Ethereum Test RPC. And since last year, it's being acquired by let's say another company, and now it's called Genech CLI. Basically, it's your local Ethereum blockchain running on your machine, which you can use to deploy and to test your apps. And what is nice is that they have also a GUI runner, which we're going to use in the demo. You'll see later. So you basically know fancy console stuff. You'll just see transactions running nicely in a separate application. Okay, as I said, this Genech CLI is a part of a Truffle. Truffle is one of those projects that produce tooling for blockchain developers. And Truffle is also distributed as an NPM module. You can install it and then init a project with it. So basically, Truffle takes care of a lot of stuff related to creating an app which communicates with a blockchain. So it takes care of deploying your contracts, of compiling your contracts, and it also basically is a provider for Web3 that you use in your JavaScript code. So now just a quick explanation where is basically how it's happening, the interaction. As you can see, when a user clicks a button or adds some information, you just initiate a transaction which goes through the Web3 into the blockchain, let's say, calls the contract. Contract is being executed. If it's correct, you get this becomes a valid transaction, which is added to the list of things that needs to be mined. Here we come to the basic concepts of blockchain. And when the block is mined, all the other nodes know about it, and they add it as a set in stone information then that any other party, also your app, can validate, so retrieve. So basically, if I press the button, send the money to somebody, and I have enough money on my account, this transaction is being validated. New block is added where it says I've sent the money to you, and then everybody in the network can see it, and that's just another block in the network. Now let's go to a quick demo. What I'm gonna do, we'll take a simple to-do list app and then extend its functionality a bit. So I have here this Ganage GUI runner. Basically, when it starts, it gives you two addresses, and as you can see, there are no blocks yet, no transactions. Everything is clean. Now we'll open the freshly cloned repository with this to-do app. What is it? It's basically a really simple React app. Is that good enough? You can see it? Fine? Okay. So it's a really simple React application which has basically list input field where you can add to-do, and then you have the list of to-dos, and then you can remove one of them one by one. So from UI perspective, it's really simple. But what is cool about it is that it, as you can see here, it employs the Web3 connector, and here you can see that it connects to the provider, which is running on our local host. This is the actual blockchain provided by Ganage CLI. So here we connect to this provider, and then we have a couple of methods, such as get info from the contract and select a contract to communicate with. Also, valuable point to mention is that the config file, which is basically quite simple, you just can define some specifics about where is your blockchain running, on which port, or it's something not on your machine, that's also possible. So here it's really simple development setup where you have everything on localhost. Besides that, if we take a look at the app structure, we have basically here a folder for build files, some configs and settings. Here you have the contracts, which we'll take a look now. Basically, the SRC folder is just your normal JavaScript code as you would have in any other application, and the config file for Truffle specifically. So let's take a look at the contracts. So here we have, again, very simple to-do list contract, which I showed in the beginning of the presentation, which has only one specific structure, which is called a to-do item, which has a name and a current status. We can add it, we can list it, and we can remove it. That's the current starting point. Okay, so what we're gonna do now? We're gonna, so we have a, let's say, raw contract file, and to be able to execute it in the blockchain, we first need to basically compile it. As you can see here, I'm doing a compiling. After compiling, we have here in this folder, we get two, oh, wait a sec. Checked it before, but something didn't work.
Is this what they call demo effects?
Yeah, of course. That's it's part of the story. Yeah. Yeah. So build contracts. Yeah, I think they're actually there. Yeah, I forgot to refresh. So in the build/contracts, we have those files, which is, as you can see, is specific JSON structure which defines a contract. Let's say it's intermediary between the binary compiled contract, which will be put into Ethereum, and something that Truffle provides you. So next step will be do the migrate. This will put the compiled contract into the blockchain. Fingers crossed. Here, okay, it worked fine, and we can see now in this GUI, we had several blocks added and several transactions. Here you can see it, it's a contract creation. Unfortunately, this one cannot be zoomed, so you have to believe me if you cannot see this. We created a contract here, and this is the binary data of this contract, and this will be executed by the nodes of our small local network. And as you also can see that the balance, initial balance was 100 Ethereum coins, but the deployment took some cash, some imaginary cash from it, because this is an operation which also requires some processing power. So that's you can see later it will decrease by each time we're doing a transaction. Okay, that was deployment of a contract. Let's take a second part, which is starting the UI. UI, as I said, is just a React application. It shouldn't take long. Here we are. So here we have this nice demo. Basically, it's now in idle mode. Let's add some to-do. Of course, let's add tests. So in the top right corner, you can see indicator that this is actually connecting to the blockchain and deploying it. So add more tests. So, and also you will see that there are more transactions added here. Those two just happened now. And again, so there are more blocks mined. I'll just put it just next to this screen so that we can see how it's growing, basically. So we do, let's say, this. You see that there are more transactions in our small network. And now we can also remove, basically, stuff, which also takes transactions in our network. Also, this GUI tool has a detailed logging, the same as what you would see in the console. So that's really, I think, a good tool to start. Okay, that's a really simple to-do app. Normally, you would also have the option to basically check the mark and say, this is done. I finally added the tests. I can get a coffee and have fun. Okay, let's add this functionality. I will cheat a bit because I have it here. So basically, the extension of a contract is to add a toggle to-do item function, which will just pick the item by its index, invert the status, and basically put it back. And the change in the UI is just add another box which will be doing the toggling, like the check mark. So here I add a toggle button. I don't know if it's visible. Yeah, I think it's visible. Yeah, add a handler to it, and basically add some UI for it. Now let's apply this change. Okay. Now we will see here. Okay, since we changed the contract, now we need to also update it in the blockchain because it's still running the old code. For that one, we'll have to do again here basically compile the new contract. Yeah, and
Question?
yes.
Old contract will stay forever in this network?
Yes. Well, until I shut down the GUI, it will be there. But if you talk about something outside your computer, it will stay there forever. Yeah, and that's actually a point when you, let's say, deploy something. You must be really 100% sure that things are working fine. Otherwise, you may lose real money, and that's the whole big topic of security of smart contracts. But there are ways basically to mitigate that. For example, you deploy one like a wrapper contract, which points to a latest version, and then later you add functionality or you cover some bugs, and then you deploy it through this wrapper, and the wrapper now points to a newer version, so that people, of course, found a way to deal with it. Okay, so now we do truffle migrate, but with a reset, because we want to override the first version. Yeah.
Can you call external service from the contract?
external service, you mean what thing? What specifically? Well, you can do it from your app, or you want to do it specifically. No, from the contract you cannot call the, let's say, outside world. So the only way is that, again, some standalone app like your JavaScript app, or let's say your native app or whatever, can check the contract status, and there may be like a status like, I want to check the weather in Amsterdam. And then the app should do the call, and then give the contract the new information. Okay, in Amsterdam it's again raining. And then the contract will react accordingly. So contract itself is just fully limited in communicating to outside world. It can only answer when you call it that way. Okay, so meanwhile we've deployed the newer version. Now let's check what we have here. So since it's a new one, we lost all the previous to-do items. Let's add them again, right? Let's go to Meetup. So we have it here. It's not, now we got this new UI piece which you can toggle the item. And again, if we look at the transactions here, if now I check the mark, I basically get another call, which means I again toggle the information in the contract. Then do a presentation, add another one, get a beer, and so on. So now I almost did the presentation, so I can check that one. As you can see, the blocks keep on mining, and the transactions are all recorded. Again, if I stop now the network, it will all disappear. But thanks to Truffle, you can deploy those things to test Ethereum network, and really everybody can try to access it and play with it. Okay, that was a demo. Just some quick word in the end. So the demo I showed you, as you see, it's quite simple version of a contract and quite simple UI. But there's really a lot of tools and tutorials how you can enhance it and make your knowledge better. There is a special web IDE, which is called Remix, where you can check your contracts and validate them and even deploy them. There are also reusable pieces for your contract code. This is called Open Zeppelin, is one of most famous projects behind it. So basically the battle-tested, security audited code, which you can reuse the same way you reuse, let's say, underscore, or I don't know, some other toolboxes, the same here. Also, something that is relevant to your question, the Oracleize, which is a service by which you can trigger events in the contract from the outside world. So that's like you can make your contract a bit more alive in terms of if the weather in Amsterdam turns out better, then it can ping the contract and say, oh, it's you should change your status or something like this. And besides of that, there are more libraries that provide useful tools for developers. There's, for example, the Diesel one, again from the same Truffle project, which has a really nice wrapper for apps using Redux. So basically you can have your state partly communicating to a blockchain, those kind of things. So there's numerous improvements, and there is a lot of things to learn. Yeah, that was it. Thanks for your time. I hope you have some questions. Debug. Well, I can show now, for example, as I said, this Solidity IDE. It has some linter and debugger in it. So basically here, right, I have the same, again, contract. If I, there's one.
It will be run in some simulated environment.
Exactly, yeah. It will, here you see it has a warning, something about, I guess, linting. Let's say if I will, I don't know, put some strange thing here, then try to start compile, it will say, of course, first I don't have it locally, so I should
well, he just keeps he sticks to his claim. So I'm very curious to hear from him what how he's going to explain this thing. So maybe if we give him a warm round of applause, then he is going to be very excited to tell us all about it. Eddy.
Thank you, thank you. So let me see. Is the mic on? Yeah, it's okay, right? So these comments really crack me up on the Meetup page. So someone asked, okay, how does someone have 40 years of JavaScript experience? And I really love the last comment up there by Ismail. Is Ismail here by any chance? Oh, it's such a shame. So he was talking about a web time travel API. I really love the comment. So yeah. So I'm Eddy, Eddy Verbruggen, and I was wondering, has anybody of you ever used a Cordova or PhoneGap, Ionic, stuff like that? Yeah, great. I was thinking. So you made mobile apps, right, with JavaScript? So that's a right audience for me. And you may have also used any of my plugins in the past, because I do a lot of Cordova PhoneGap plugins and also NativeScript plugins these days. So this is where I live, my GitHub. And here's a top tip for you as an open source developer. Try not to make these top bars green. That's the weekend days. You should do other things. So also, don't take up so many projects, just do 1 or 5 at most or something. I have a lot of small projects, some get a bit larger, but you get a lot of issues and not that much pull requests, unfortunately, and emails and tweets and Slack messages, so it's a bit much. And all this stuff is published to NPM, and I was looking at this graph. It's the download summed of all my packages that I published there, and only last year it was 13,000 a month, and now I'm almost at 250,000 a month. So stuff is getting more popular, and you get more to do as well. So as you can see, there's a lot of commits, and there's a lot of stuff coming in. So how the hell do I do it? Because I also have a day job, by the way. This is mostly just for fun. Some of it is paid, but I also have a day job. So how do I do that? Well, the answer is simple, and it also explains why I have 40 years of JavaScript experience. I have a bunch of clones running around working for me. And they come in pretty handy because I only have 30 minutes to cram a lot of content in this presentation. So let me introduce a few of my clones. It's Mr. Cool, it's Mr. Nerdy, Mr. Siesta, and Mr. Sporty over there. Thank you. So let's take a little step back and talk about mobile app frameworks. So there's a lot to choose from them these days. And well, I asked one of my clones to create a nice and handy diagram. Here it is. And I assume you can all read it, right? No? Didn't think so. So it's time for my first clone. It's Mr. Sporty, and he has a black belt in diagrams, so that comes in handy. Oh, it's a black sweatband, actually.
So let me walk you through this diagram now. Which mobile app framework is right for you?
Okay, do you want a native user interface?
No, I don't want a native user interface.
I just want to use a web view. Okay, use PhoneGap, Cordova, Ionic, Awesome, anything that runs in a web view. But if you're not sure, okay, ask yourself, do you live in the year 2015, or do you have a lot of resources, people, skills to pull off a native iOS and Android app? Then go ahead and do that. But if you, like us, live in the hybrid era, and most important question here is performance important to your app? If you're not sure, okay, do you need full native SDK access? Probably not. Is for a platform-specific UI important, and UI that upgrades with newer OS versions? Well, no, not really. Okay, then still you may consider doing a PhoneGap or Cordova-based app. But if any of those questions you answer yes, then go over here and well, you can ask yourself, which framework or language do you like most? Like, is it C#? Okay. Then do you need to share code with web? Oh, no, not really. All right, then Xamarin is probably the one for you. But if you need to share code, then you have to consider other languages. But otherwise, if you're very much fond of Dart, like I am, the game, not the language, then you can use Flutter, but it's still in beta. It's by Google, and it's pretty nice, but you can also not share code with web. But if you like React,
then you can share code with web all you like. Do React Native, no issues there. But if you like any other framework or language like Angular, and there's NativeScript with Angular, and if you don't like frameworks at all, you can do NativeScript with just plain old JavaScript or TypeScript. And if you like to do cool kit on the block like me, then go with NativeScript and Vue. Now I'm off earning some more medals. Cheers.
Thank you, Mr. Sporty. So a lot of those frameworks pointed to NativeScript, right? So not a coincidence because I'm talking about NativeScript. And by the way, if you want nice NativeScript socks, there are a lot of socks over there, and there's also a box, so everybody can grab a pair after the talk. So where do I start with NativeScript? Vincent is wondering. Well, we have a playground, Vincent, and Vincent will now show how it works. Yeah. Down there, all right. So, no, well, thank you, Vincent. That was really helpful. As usual, I have to do it myself. So go to play.nativescript.org, and well, I have a clone set up for you. It's Mr. Nerdy. Take it away, man. You're on, man.
Oh, hi. How are you doing? Don't answer that. I don't really care anyway. Let me show you around at play.nativescript.org. So I started a new NativeScript plus JavaScript project, and the files are over here. And at the bottom you have these components you can throw on the canvas, and this is your canvas where you can see there's a few labels on the screen already. So if you're happy, then you can scan a QR code with your app. In this case, I have my iPhone 10 with the Playground app. Scan it, and there's also an Android phone, which I'm going to use to scan the QR code as well. And you can see that it fires up the app and it loads your playground. So to prove to you that it is connected, let's throw away these labels and throw something else on the canvas. So let's look for a pie chart, and let's look for a progress bar. So what you can see here is that the pie chart is as a data series bound to an items property, and the property is called pie source, and there's also a property called progress value for the progress bar. And let me change this real quick. I can see that there's a stack layout with a class home panel, and in the CSS file there's the home panel as well. Now I'm going to align everything to the top because the progress bar wasn't in view, but now it is. So let's go to our observable, which is tied to the XML file. It has this progress value and this pie source property. And let's refresh that. The progress bar should now initialize at 0. To make it a bit more interesting, let's throw in something I prepared. There's a progress bar that's filling. Every 10 milliseconds, it adds 1% to the progress bar. So that's how you use.
What about TypeScript, man?
Sorry. Yeah, I was just going to say that it's also TypeScript. Thank you for interrupting. So NativeScript plus TypeScript is another flavor you can use in the playground. And it's, oh, there goes my TypeScript sticker. But you're up, buddy. Let's stick in there and let's throw JavaScript away. So it's the same thing, really. It starts out similarly. You can throw away some labels, and you can throw, for instance, a calendar on the canvas, which is pretty nice. There you go. And yeah, once you're happy, you can save this project, and you can copy this URL and share it with your buddies. They can install it on their device as well, so that's really nice to prototype some stuff. And also, if there's a bug or anything in your code or in NativeScript code, you can share that playground URL with anyone else that can take a look at it. And also, once you're really happy and you want to develop locally on your machine instead of in the cloud, you can press this download button over here, and then you'll get all the sources on your file to get up and running with the NativeScript CLI or Sidekick or anything.
Yeah, you're done yet?
So.
Done?
Oh yeah, that's it.
Okay.
Bye-bye.
Thanks. So that's pretty nice. Sorry for the corny Dutch joke. So the diagram mentioned NativeScript with Angular. So now we've seen JavaScript and TypeScript, but Angular, well, personally, I really love that framework, and also Vue, but Angular just a little more at the moment. So how do we get started with that? And perhaps the man with the microphone needs to come back, because we're going to ask Mr. Siesta to explain it to us. Hey man, wake up.
Oh, is it that time already?
You're up, man.
Oh, yeah, sure. I'll show you around in the playground from NativeScript with Angular. I just started this new app, and it generates this project for you. And I've opened the app module where you can see that there's an app routing module being included in here. There's this file. So if a blank route is hit, that's when the app starts, you'll be redirected to home. And this is my favorite feature by far. It's lazy loading. I love it. Yeah, and so it loads the home module. The home module has a routing module as well. It loads the home routing module. Of course, you can structure this any other way, but this is a nice way to structure your Angular app, I think. So it has a route, a blank route that loads the home component. And home component, you've seen this in Angular 2 to 5. This is 5 actually. It's all the same way to declare your component. There's this template URL, it's just this HTML file, and there's styles as well. So let's open up the HTML file. You can see that there's an action bar, and let's add something to the action bar. Let's search bar in this case. Let's try it again. And save that. And also there's this scroll view, which we will blow away and replace with something I've prepared already. This red layout that renders images. And every image in here has a text, 1, 2, 3, 4, 5, 6, and an ngIf, like any other Angular ngIf you're used to, which determines whether or not this image can be rendered based on if there's no search phrase or the search phrase matches one of these numbers. So let me try this on my phone over here, and let me include 1 and 2, and nothing happens. And that's expected because in our component, the playground has automatically generated this search phrase file. And now I'm doing voice input for some reason. And this search phrase is, well, initialized as nothing, and I can initialize it as 2 in this case. Come on, internet is still working. And then you'll see that this property is bound to the view, but I'm binding it like this. It's not two-way binding. So if I type down something, it's not sent back to the model. And because of that, this value here doesn't change. But as you can use any Angular feature you like, you can also use ngModel over here. Save that. And now you can see that if I change this 2 to something else, 4, 5, or 9, everything is working as expected, right? So you can use any Angular feature in the playground as you expect, and in NativeScript as well, of course. And now I'm back to my siesta. See you.
Night, man. Thank you. Very nice. So you can use Angular in much the same way as JavaScript and TypeScript in NativeScript, using largely the same UI. Those components are all the same UI, and it automatically renders code behind properties for you as well in the playground. So, but we also saw that you can use Vue with NativeScript, right? So how many of you are using Vue these days, I'm wondering? So that's quite a few, right? So probably because it's new and cool. So let's ask Mr. Cool how that works with NativeScript. Hey man.
Hey Eddie, how are you doing?
Good, time for a drink already?
Yeah, man, it's almost midnight over here. I gotta relax a little, right?
Yeah, sure.
Have you checked out the Vue yet?
Awesome joke.
So if you add a new NativeScript plus Vue.js project to the playground, you'll get something that looks like this. There's a Vue with a template, which should be pretty familiar to you if you've used Vue at all. But let's add a few things so I can show off some features. So here's a time picker, which has data binding to an hour property and a minute property. And those properties have been added to the data section over here. And it will just return the current hour and current minute. And in both cases, it's 2:12 already, so I told you it's midnight almost. So you can scroll these. I'm trying to use a simulator, but it's actually a real device that I've connected. So let me scroll these babies to other values to see that it works. And there's also an Android device lying around here. And you can do the same. So now let's add something else. For instance, a list picker. This will also render a few pre-configured things. In this case, a country list, where I'll scroll over here, and I'll scroll over there, and you'll see it changing. And it has added a list picker countries property and a selected picker index to your data section. You can change that, so the initial value will be something else than the first item. So now the first item selected is Bulgaria, so the third item, the second index, right? So now the last thing I'd like to show you is you have data, you have template, but there's also methods in Vue. So you can add those as well. And I want to add a method that console logs the selected index when you change the country selector. So what we have here on the list picker, there's an items which has been bound, there's a v model which has been bound to the currently selected index, but if you change something, there's a selected index change event that is fired, and you can bind that to a function of your own. So I'll bind that to changed country, something like that. So this is a method that I can reference here. So there will be a change country method, which is a function which has arguments, and the implementation looks like, well, console log, like I said. And what I want to log is there's an object over here which has a selected index property. So let's see if that works as advertised. So let's open the device log over here, and on my iPhone I'm scrolling to the United States, which is the last index, and the first index is Australia, which is index 0, and as you can see on the Galaxy S8 I've connected as well. I'm scrolling to the first item, and then you can see the selected index being logged as well. So I think that's pretty cool. Yeah, I'll hand it over back to you, Eddy, and cheers. And by the way, make sure you give these nice folks a NativeScript sticker, because they're pretty awesome. See ya, cheers.
Oh man, so that's Mr. Cool for you, making promises I can't keep. But instead of the stickers, I have these socks, right? So grab them from there later on. So working with Vue is similar to Angular and TypeScript and JavaScript as well, so that's pretty nice. So is everything perfect then in the playground? Well, no, of course it isn't. There's a few things it doesn't support, like .vue files, but you can download your project and then use a Webpack template we have, and then use Vue files actually, with all the IDE support that you'll get from that. And debugging, well, so there's a device that runs this wrapper app. It's a bit hard for a cloud service to debug that device, right? So, but arguably you can still debug, because my favorite tool is console log, and you saw that that's possible. So, and also, yeah, most plugins with third-party dependencies cannot be used in the playground. You can use all the plugins that don't use third-party libraries, like CocoaPods and AAR files, and a few have been supported in the wrapper app. And if you want to know which ones, then you can connect an app, a device to the playground, and then you can see the entire list of supported NativeScript plugins here. And also, you can download the project here to run it in, well, the NativeScript CLI or Sidekick, which is a nice way to, for instance, deploy iOS apps on a Windows platform. So let me give you a little demo talking about plugins. That's my daily work really. That's what I love and do. So let me show you a few. I hope that, yeah, they're here already. let me find my mouse. So I have this simulator over here, and I have a real device lying around over here, and I have this plugins app. I have to look behind me because I don't have it mirrored here, so I have to be a bit rude and look there. So you may be wondering what's wrong with the monitor. Why is at the top, why is it lighter than at the bottom? Well, actually it's the gradient plugin, which has 2 colors defined, and it will just give you this nice background gradient, so that's a plugin already. And then over here, there's the material design actual hamburger icon with a bit of cheese leaking over your meat. I really love it. So that's the font icon plugin. And there's also this drawer over here, which has a nice transition effect. Of course, there are multiple ways to have a drawer. You can also overlay it over your page and not push it away, etc. But I really like this effect. And also, there's this shadow going on just between the blue and the green. And at the bottom, you can see it as well. And that's not by default possible when you install this plugin. And that's a nice thing of NativeScript. So with your JavaScript or TypeScript, you have full access to the APIs that NativeScript provides you. So NativeScript exposes the iOS and Android SDKs through TypeScript definition files. So you get code completion in your JavaScript and type checking as well. And you can drill down into the native classes if you like and add, well, fancy features like that shadow. So there's a lot of plugins in here, but I'll just not waste your time too much and show you a few cool ones. I really like this one. This is my, poor man's Siri, where you can speak. It will parse your language and then you'll get a text, and then you can parse the text in JavaScript, of course, and do a few fun things. So let me try to say something here. The quick brown fox jumps over the lazy dog.
The quick brown fox jumps over the lazy dog.
So it's not too shabby. It takes the language of the default language of your phone. In this case, it's set to English. You can also set it to Dutch, of course, and there are about 40 languages or something that's supported. It's just the Siri engine that's powering this. And on Android, it's also, I'm not sure what it's called, but it's the assistant. Yeah, probably that's powering the Android side of this plugin. So you can also do a few fun things with these sliders over here. You can change the pitch. I don't know if you've at any time looked at the Windows font dictionary and took a sip of helium, then you would probably have heard this.
The quick brown fox jumps over the lazy dog.
And if you're a font smoker,
The fox jumps over the lazy dog.
then please stop smoking, because eventually you'll sound like this.
The brown fox jumps over the lazy dog.
Not too good, right? So let's put them back in the middle again a bit.
The quick brown fox jumps over the lazy dog.
So like I said, I have a few Siri fake things in here. For instance, this one. What's my schedule today?
Your schedule is clear. Have a nice day.
Oh, okay. So oh dear, is this going? Did I just kill it? I think I just killed it. Oh man. That's amazing. Did I? No, it's this one. Phew. All right. So what I wanted to do was this: go to home, add something to my calendar over here, and then that shouldn't be too hard, I think, in this venue. So let's go back again here and do it again. Actually, I can just fake this by just tweaking the slider a bit, because you repeat that last sentence and parse it again.
What's my schedule today? Find a bar and get drunk in 24 minutes.
24 minutes, guys, so hang on. So there's another one which I really like. That's the last one of this plugin, but it's a bit hard to pronounce. Here we go. As sure as Kilimanjaro rises like Olympus above the Serengeti.
Insurance.
Does anyone recognize it?
Rises like Olympus above the Serengeti. That sounds like Toto with Africa, right?
Yeah, it is. Listen. Thank you. I really love this song, but I never knew what he was saying, so there you go. Something with rice and insurance. So But you may wonder why did it pick up this song? Well, I only look for in this string for an index of 3 words. If any of those 3 words match, then it will say, hey, it's Toto with Africa. So it's Kilimanjaro, Olympus, or Serengeti, and I got them all 3 right. So it was pretty safe this time. So now I can throw. Oh. So this app ships with only 1 song, so it's a bit hard. I can try, but it will fail. Here, so let's see if my iPhone will wake up. Yeah, it's awake. So on hardware, you have a few more possibilities. So there's AR, which I'll come to in a second. And also there's mapping. That works in the simulator as well, but it has a bit less grunt than this device. So this is Mapbox powering this plugin. Sorry? Yeah, well, it's not entirely accurate. You'll probably end up at my neighbors or something. But yeah, you can press here and get directions to my home. But I think it's still set up to use a waypoint. So it's not a direct connection to my home. This will trigger the NativeScript directions plugin. It's looking for the location here. And you can see there's a waypoint in Bulgaria. And then to my home. It sounds like an efficient route, right? So the reason it opened Google Maps in this case is that Apple Maps doesn't support waypoints when you open it through a custom URL scheme. So if you pass in waypoints, the plugin will use Google Maps if that's installed. If that's not installed, we'll fall back to web actually. So let's go back to wherever that app was. You saw something, right? So there's also, let's go back to mapping once more, because I want to show you custom markers. So you already saw that one, and there in Bulgaria there's a few as well. And here's where my clones live, by the way. This one lives in Austria, Mr. Sporty. And there's one in Finland. He's a bit laid back. And also I was in Bulgaria actually, and this truck driver hit me. He lives over there, and we had an insurance nightmare with him. But so I'll just leave them in here for fun. And there's also Mr. Siesta is living over here, and there's also one at Aruba, I think. Yeah, that's Mr. Cool. He should live in Aruba, but he's off the coast. So he's probably in a boat chilling or something. All right. So that's Mapbox. It has a lot of nice features. Also a live traffic map and everything. So you can check if this would be a good time to go home. Let's check that real quick, because this is actually the traffic map that I've loaded. It's mostly green. In the direct vicinity, it's a bit more orange, but it's good. So don't drink and drive, by the way. So also app icon is pretty cool plugin. You can add deep links if you like. And like I said, my wife is gonna love this picture. Sorry if you're watching the live stream. So these are 3D touch icons, and since Android 7.1, you can also have this on Android, which is pretty cool. And iOS has it since version 8 or 9, I'm not sure, where you can deep link into certain pages of your app. And you can bundle those deep links in your app descriptor, but you can also add them at runtime. So in this case, I'm adding one at runtime, and now you see there's another deep link there to mapping. Let's go there, you can see, whoop, now it opens the mapping route. So the routing, of course, your app gets a notification that it was loaded with a certain link, and then your app needs to route to the correct page. And also with app icon, this is a bit funny. Since iOS 10.3, you can change your app icon on the fly. I don't know if any of you saw it happen on an app. You will notice, because when you press the button to change the icon, you will get this prompt. And there are ways to remove this prompt, but it's a bit cheating, and Apple frowns upon it. So the user will be notified when the icon changes. So you can't really do a nice background weather-based icon or something. So that's a bit of a pity. So and the last one I'd like to show you is AR. I did this demo once, and it was very hard to recognize the flooring. So that's why I added this flashlight as well. But that's actually no problem. So what it does is it tries to detect horizontal planes. In future versions of ARKit, you'll also be able to detect vertical planes. And AR Core on Android has the similar things. Only that has been there's been a final release like a few weeks ago. So before it was still in beta. But this plugin is now working with ARKit, latest versions, and on AR Core. I'm currently working on getting up to par with what you can do on iOS. So let me remove the statistics and remove the planes. So there's a plane lying over there, and a plane can be used to drop stuff on. You don't really need to drop stuff on a plane. You can also just make it float in space, but this is nicer for a demo. And let's stop detecting planes as well, and then you can throw stuff on here. So here's NativeScript boxes. I don't have them on me. So a friend of mine actually has made a stress cube which resembles this layout, which is pretty cool, and he hands it out at conferences as well. You can also tap and hold to remove these things, and I always try to stack them, but it's pretty damn hard. But yeah, it's pretty cool. You can see yourself in the background.
Make them fall off the platform?
Yeah, good question. So I'll draw the planes again, and you can see where the platform is, and they tumble off. Yeah, like when they're about 40 meters deep or something, then they get removed from the scene. Otherwise, well, your poor little iPhone 10 processor will give up at a certain point in time. So there's this huge plane at the bottom that detects hits of those boxes, and then when it hits it, it removes them. And, well, of course, you can do other models as well. So, for instance, here's a tube, which is pretty large. It doesn't fall, it just drops in place. Oh, here, it tries to stand up there. Here's my foot. Yeah, there it is. So that's AR, pretty well. I'm not sure how to make a real use case out of it, but it's nice to play with, right? So, sorry. So let's get back to the presentation. I'm almost done. If you'd like to try the app on iOS and Android, you can scan this QR code. On iOS, by the way, you can just use your camera app. It will scan QR codes these days. On Android, you probably have an app or something. And I also have a few resources. If you want to look at that code, so this was a NativeScript with Angular app. That's the source code up there on my GitHub. And if you like to see what plugins are out there, which templates are out there for NativeScript apps, there are about 750 plugins or something right now. Then go to market.nativescript.org. Great NativeScript courses. My t-shirt was sponsored today by nativescripting.com. And also have one to give away, by the way. And if you want to fool around, go to play.nativescript.org. It's pretty fun to do. And well, now my clones want to say one last thing to you.
Thanks for having us, and have lots of fun using NativeScript.
Thank you very much.
Thank you very much. Also, thank you very much for the socks. I'm going to grab 2 of those.
Yeah, sure.
Also, please thank your wife for her valuable contribution tonight.
I will.
I mean, without her, it wouldn't have been the same. I think we can all agree. And thanks to all of you, of course, because tonight was yet another great edition of AmsterdamJS. Let's have a last drink at the bar and see you around.